Hello. So in this week's General Chemistry 2 experiment, we did the iodine clock reaction experiment. And the iodine clock reaction is a basic chemical demonstration that shows you chemical kinetics in action. It is involving two colorless solutions that when combined they create a color solution. So this experiment was pretty interesting. So first we have a solution A, colorless solution A, and this solution is vitamin C and distilled water, crushed vitamin C that's been filtered through so all the extra stuff isn't in it, but vitamin C and distilled water. And what's interesting about this solution is that when I combine iodine, which is a very dark solution, that colorless solution doesn't change. So the reason why the color doesn't change is because iodine, which is I2, but when it comes in reaction with vitamin C, the vitamin C turns it into an iodide, which is an I-, which is a colorless solution. So I will show you here. So there's colorless and very dark. And when I add them, there's no matter how much I add, it always stays colorless. So that was really cool. Solution B is another colorless solution. And in this solution, we have cornstarch and hydrogen peroxide. Now with solution B, it was a little bit more different because when I added the distilled water, it was very, very, very cloudy. So what I had to do was I heated it up in my microwave until it was boiling, which took about 4 minutes. And then I filtered it through probably like 2 times to try and get it as clear as I possibly could. And then once I got it as clear as I possibly could, I added in my hydrogen peroxide, which still it's a pretty clear solution. But what we did in this solution is we combined actually this one and this one. So we combined in 1 cup solution A and solution B, and it actually gave us a very dark color. When the 2 solutions are mixed, they have a reaction that you wouldn't expect. And they actually, when they mix, they have 2 reactions that is going on at the same time, and they're kind of competing and going back and forth against each other, and then one ends up getting wiped out by the other, and that's when you get the dark solution. So one of the competing reactions is the hydrogen peroxide wants to oxidize and bring the I- ions back to I2. And the other one doesn't want that. The other reaction doesn't want that. The other one is the acid, and that wants to reduce it and make it go back to the I-. So one reaction wants it to go back to I2, the other one wants it to go back to I-. So they are competing with each other back and forth, and eventually the I- loses because the vitamin C gets consumed, and when the vitamin C gets consumed, it can then be a color solution. So when I combined the 2, this is what I got, which is pretty cool. I was a little nervous at first when I did it because when I combined them and I stirred and I mixed from cup to cup, it didn't turn as fast as the video showed, but it took about 20 minutes and I just looked over and it was black. So that was pretty cool. So this solution is not iodine, it is a trioxidite solution. So it's a completely different solution than the 2 solutions that we had combined. So it created its own solution, which is pretty cool. So 2 clear solutions gave us a very dark solution. This is another one I did. I tried to see if I could get it to go faster. So one of the ways you can make the experiment go faster is if I was to warm up both of my solutions. So if I was to put in the microwave solution A and solution B in the microwave and then combine them, the reaction would happen quicker because the vitamin C would be able to break down faster, and vice versa. If I had it in a cold or a colder solution, it would take a while, which is probably why my first one took a while, because it wasn't as warm as the second time I tried it. Another way that it would probably happen faster is if you had more hydrogen peroxide, because the more hydrogen peroxide you have, the more it is able to break down the vitamin C. And vice versa, if you have more vitamin C in the solution, then it's going to try and hold on to that clear solution longer because there's not enough hydrogen peroxide to break it down. So it's a pretty cool solution, but eventually it does go back to a colored solution, but a completely different colored solution. So this was a very cool experiment. Thanks.